Hello. In today's digital control systems technology lesson, we are going to be looking at basic electronics. The main idea for today's lesson is to have a revision and recap of various different modules that you may have covered previously around electronics and thinking about some of the key concepts that would be relevant to some of the future lessons that we will be having. So today's lesson will be fairly short and we will be covering some of these main theoretical topic areas, and at the end of the lesson we will have some practical activities that you may be able to do on your own time, and later on we may also cover some of these things in a separate tutorial lab activity class. We will start with understanding what electricity is. Given most of the digital systems, digital control systems, electricity is going to be the fundamental, one of the fundamental things that we will be dealing with. So, to understand electricity, it is basically what we have as flow of electrons. So, when we have electrons in a material, and if the electrons in that material is moving from one place to another, then we can call that electricity. And depending on the flow of these electrons, we can categorize these electric signals into two. One is what we call as alternating current, and the other one is called direct current. So AC or alternating current is what you get through the power supply from your wall socket at your home or an office. Direct current or DC is what we get from battery powered devices or from batteries. The main difference here is in direct current, what happens is electrons flow from one direction to the other. There is a set direction on which they flow. Whereas with alternating current, they change direction in a particular frequency, or in a particular frequency they will change direction of flow. So again, when you think about the power supply or current supply to your home, you may think of a 240 volt power supply with 50 hertz. So that is what we see in a alternating current. Then another important factor when we think about electricity is about conductors and insulators. So there are certain materials that can conduct electricity or that can allow the flow of electricity through the material. Those we identify as conductors. And on the other hand, insulators are materials that prevent the flow of electricity. So good examples for conductors are metals, and examples for insulators are rubbers or plastics or similar materials. Then when we think about electricity, another concept that we will talk about is what is called circuits. So when there is a conducting pathway, so we should use a conductor. So material should be a conductor. So we have a conductor, and then that conductor is connected through a pathway that is interconnecting from the start to end. Then we call it as a closed circuit. So it is closed. The beginning and end are closed. And an open circuit, on the other hand, is when we don't have that connectivity completed. So there is a gap there and that connectivity is not completed. So there can't be a current flow. In a closed path, we will have current flow, and in an open circuit, we will not have any current flow happening. The next concept that we will be talking about in relation to electricity is voltage and current. So voltage is basically what defines as, say, an equivalence that we can think about is how fast something is moving through that medium, or the force that they have when they are moving. So that is the voltage that we have. So how much electrons are moving, or how faster they are moving. Whereas on the other hand, current is basically the amount of flow. So voltage is about how fast and current is about how much. So, and typically we would represent voltage using the unit volts and current using the unit amperes. And another equation that we may use quite a bit is this, that is power equals voltage by current. So for example, let's say you have a 240 volts power supply and 5 amperes are being taken from that, then what you have is a power you can calculate by multiplying the voltage and current. And this same equation can be restructured like this as P equals IV, or I equals P over V, or V equals P over I. And these variations may sometimes be used to do different calculations depending on what we have and what are the fields that are already known. Then when we connect the systems, or when we connect the devices that we have, and we connect different devices to electricity, for example, we will come across another property of materials that is called resistance. So even when we have conducting materials that can transfer electricity from one end to the other, there would still be some level of opposition for the flow of electricity. So that opposition for the flow of electricity is what we call as resistance. And the unit for resistance is ohms, and the symbol is normally omega. Again, with this, we have what is called the Ohm's law that defines the relationship between current, resistance and voltage. So the basic format of the Ohm's law is V equals IR. So the voltage between a particular 2 points is the current flow, and the multiplication of the current flow and the resistance of that particular material. Again, we can restructure this equation, the Ohm's law equation, and this may become useful when we are doing certain types of calculations and computations relevant to our circuits and so on. Then when we think about connecting things, electric devices in circuits, we can have two different ways of connecting them. One is called series and the other one is called parallel. So when it comes to series, what we have here is all the devices that we have here are connected one after the other. So when they are connected one after the other, we identify that as series. So here what happens is, if the electric flow is from the battery, it will go through all the components that are part of this circuit. So it will go through one after the other to reach the end point. So it will start from here, go through here, go through these, and come back here. So that is series. The alternative what we have is called parallel, and in parallel what we can have is, say for example here, these two bulbs are connected in parallel. That means they are connected, or the electricity can pass through either of them to reach the other end. So the reach of electricity or the flow of electricity is not limited or not controlled by limiting to it only going through one of these. It can go through both of these in parallel. So it can pass through both of them at the same time. So that is the main point. It passes through all of them at the same time. So that we will identify as series. Then when it comes to thinking about resistance, again this is extending from the basic Ohm's law and applying the same equations that we have covered previously. We can arrive at these additional equations to calculate the overall or effective resistance of a circuit. So if it is connected in parallel, we may use this circuit, and if it is connected in series, we would use this circuit. Okay, these are based on Ohm's law, and you can fairly easily work out these using the equations that were identified here. So this is a simple example for you all to try. You can just simply apply the basic Ohm's law equations that are identified here. For example, you can use the resistance calculation equations to calculate the overall resistance for these resistors, for example, for this first example, and then you may use one of these equations to suitably calculate what is the missing value there. Say for example, we can say the overall resistance for this one is, because this is in series, that would be 12 plus 8 plus 4, that is 24 ohms. Then the voltage is also 24 volts. So now if I put it in the, so we know volts, we know resistance, so what we are missing is I. So then I can use this equation, that is I equals V over R, rather this one, and so I can use I equals V over R. So then that would become 24 over 24, so that is 1 amp. So then now I can use the same equation, or similar the other alternative equations, to calculate the voltages between these 4 points. So that is what we are trying to do. So we are trying to calculate the voltages between A and B, B and C, and C and D. Now to do that, now we can use the equation V equals I R. So now we know the I is 1 ampere, and given the current is going through all along, it will be the same current that is going through, so we can use the same 1 ampere here. So then that becomes 1 into, say here it is 4, here it would be 8 and 12. So first one is 4 volts here, so this would be 4 volts, this would be 8 volts, and this would be 12 volts. So similarly, you can do a similar calculation for the other example as well, where you can first start by bringing all of these values together. Say you can consider this and this as parallel, and then combine these two together and combine this as a series, and then this combination and this combination are in parallel. You combine those two and take this one along as series. Now you can calculate the overall effective resistance. So you calculate the resistance for all of these as a single, and then with this one you calculate the I value for this, and then from there you can calculate the voltages across all the different resistors. So this is an example that I would urge you to try out and do the calculations on your own. Now let's look at some of the basic electronic components that you would come across, particularly within this course when you are building different digital control systems, when you are working on these building different circuits and so on. These are some of the very basic electronic components that you would come across, and we will briefly look at some of these. So resistors are basically what they are. So they add resistance to an existing circuit. So they just add resistance to the circuit in the form of an additional component. And by adding resistance, what happens is it reduces the flow of electricity. So for example, if we have, say, in a circuit, if we have, say, a 1 ampere electricity flow, and we need to reduce it to, say, 0.5, then what we may do is to do the reduction part, we will have to introduce a resistor. So we may add a resistor into the circuit, and that can reduce the overall current that is flowing through the circuit, because, say, I equals V over R. So in that case, what will happen is, say, if we have a constant voltage, then by increasing the resistance, we can reduce the I. Say, if R goes up, I would come down. So that is the basic idea of why we would want to use resistors. The main reason is to reduce the current flow through a circuit. So we introduce resistors to mainly reduce the current flow to a particular circuit. And when it comes to resistors, there is a particular way of reading the resistor values from the actual resistors, or rather the physical devices. So there are certain mechanisms or certain color-coded mechanisms to identify and read these resistors. So again, you can try out some of these examples later on. Then in certain circuits or in certain usage of electronic circuits, what we may encounter is a situation where having a resistor is not enough. We may also need to change the actual resistance. So as we said, having a resistor, what you can do is you can change the current flow, either increase or decrease the current flow by increasing or decreasing. But this change, sometimes you may want to do not as a constant but as a variable. So you may want to increase the current at some point, and then later times you may want to decrease. Sometimes it is increase, sometimes it is a reduction. So that change you can achieve using a variable resistor, and we call them potentiometers. So typically there will be devices that will have a knob that you can use to control the value, or can change the value, and then it can be like a knob or a slider, and you can change that to change the applicable resistance value. So instead of having a fixed resistor, we can have a variable resistor that can go up and down as needed. Then another type of electronic device that we would use quite a lot is what is called a capacitor. And the idea of a capacitor is it can store some electricity. So it is, in a basic manner, we can say it is a storage device for electricity. And when there is not enough electricity flow happening within the circuit, the capacitor can provide that electricity by discharging itself. So initially, say for example, if this is connected to a circuit, initially it will charge itself, but when the current flow decreases below a particular level in the circuit, the current can go back into the circuit from the capacitor. And within capacitors, we may find a couple of types. One is called ceramic disc capacitors. They are not polarized, so that means there is no plus or minus side or positive or negative side. Whereas certain other capacitors like electrolytic capacitors, they are typically polarized, so that means they have a positive side and a negative side. So depending on the devices that you use, you may have to appropriately choose the type of capacitor, and you may need to connect them appropriately if they are polarized capacitors. Then another type of device particularly that we would use in circuitry, which is specifically polarized, that means it has a positive and negative side, that is what we call as diodes. So the main thing is they are polarized, so they will have a positive and a negative side. And the main point is they will allow electric current flow only in one direction. So they will allow flow of electrical current in only one direction. So that means if current can flow this way, it cannot go this way. So this is again will be very much useful in many different circuits. That is, if we want to limit current flow into a particular direction, if you want to limit, say, it can flow this way or the other way around and not both ways. If you want to do that, then we may have to include or introduce a diode into that circuit. Given it is it can be a polarized device, so it is a polarized device. It has two sides, that is, it has a ring side that connects to the ground or the cathode, and the other side which connects to the power or the anode. So that is a positive, and ground or the cathode is the negative side of the diode. A variation of diodes is and something that you would use very much in many projects and so on is what is called a light emitting diode. So these are basically have the properties of diodes in terms of one directional electric flow, but in addition to that, when the electricity passes through them, it will light up. So whatever the color, depending on the color of the LED, it will light up in that particular color. So again, this can be used similar to in a diode situation, but one of the main things to remember is LEDs don't have any resistance in a circuit. So to limit them from, so say if they don't have any resistance, or if they have very low resistance, so if the resistance is low, then that means the current flow can be higher. To avoid that, one of the things that we may do with resistors is inline to the resistor adding another, inline to the LED adding another resistor there to reduce the current flow, then in turn protecting or preventing the circuit from short circuiting and so on. Then another interesting electronic component that you would use quite a bit is what is called a transistor. And the transistor is basically a 3-pin device, or it has 3 poles. And each of these, what happens is, if there is a voltage, or if there is a current between two parts of the circuit, then it will also allow current flow through another part of the circuit. So if we can introduce a voltage through these 2 pins, for example, then that would mean the voltage through these 2 pins is also now happening. So that is the main purpose or main way transistors would be used. So it is in a way a device that can function as a switch, because if there is a current flow between say the base and the emitter, then it will let the current flow between collector and emitter. There are 2 types, NPN and PNP transistors, and again these are some of the things that you would have covered previously in basic electronics. But in the context of this course, what you need to remember is this property of transistors can be used as a switching mechanism to allow a particular circuit to switch on when another part of the circuit is active. So these are some of the ways that we may use transistors in our projects. Then another interesting concept that we would come across quite a bit in electronics is what are called integrated circuits. So what integrated circuits are? They are basically a way to fit a number of a circuit. So we are having a circuit, but we are fitting it inside a chip. So basically it can be a detailed electronic circuit. If we can minify that and put it inside a chip, then we can call that an integrated circuit. And in the context of this course, we may revisit concepts of microcontrollers and other different circuitry that can be built as integrated circuits or ICs. Then in addition to these, when you're actually building the various projects as part of this course, you may use additional things like batteries, different type of switches, and even things like prototyping devices like breadboards and wires and cables and all these things. So all these things would also can be considered part of sort of an electronic circuit, and hence as electronic components. We will get to using these in our practical activities and project activities when we start doing that. So that basically concludes our brief discussion into various basic electronic concepts and basic electronic devices and components relevant to this course. And as part of this particular lesson, there are also some experiments, some basic experiments that you can try out using simulator software or even an online based simulator platform. You can try out some of these things even if we don't practically get an opportunity to do these in a lab environment. There are 5 different experiments included in this particular, as part of this particular lesson, and a bit more details about these activities will also be included along with this lecture in a separate document, so you can also refer to that. But even without that, you can try out these things on a simulator, an online based simulator, or installed simulator. And if there are any particular questions in trying these and doing these, please feel free to let me know. Other than that, that's all for today, and we will continue with another topic in digital control systems technology next week. Until such time, thank you for joining in today's lesson. See you next time. Bye.